Welcome everyone, Professor here. In this video we're going to be looking at commercial roof replacement and whether or not insulation needs to be installed at the time you re-roof. This is going to be our second video in our regulatory topic. It is a very complex issue, is one that's going to be very difficult to break down in terms that an owner or a design professional or a code official could actually digest. That's what we're going to attempt to do today. It will be keyed around the International Energy Conservation Code, the IECC, and that's in and of itself the crux of why it is going to be so complex. This is a code that most professionals, even building officials, are not as well versed in, generally speaking, as other building codes. We will be looking at the 2018 edition because that's the one that currently has widespread adoption. The current new code of 2021 has not seen that widespread adoption. More than likely won't see it either, just because most jurisdictions take it every other cycle for their code adoptions, which would lead to 2024 to be the one that we'll start to see, again, widespread, unless there's other reason for the 2021 to be adopted. But at this point, probably will not. The 2018 IECC introduced Chapter 5. This is for the first time in the IECC, a chapter on existing buildings. This was great news because it allowed us to now look at existing buildings differently than new buildings. However, there is a caveat. In Chapter 5 about re-roofing, it does reference several sections of the Chapter 4, which is new construction, in and of itself, giving some of the complexities of what we're going to be looking at a little later here. Now, please understand, we're going to be under the CE, or the commercial portion of the Energy Code, which is the front portion of the book, and behind that is the RE, or the residential. We will not be addressing the residential in this video. However, if people leave enough comments and want to see what's in the residential, we may explore that in a future video. Please, if you have not seen the deferred maintenance video, you may want to watch that just to get a little better idea about the preventive maintenance, the PM versus building renewal, because those will be the two things that will imply heaviest on what we're doing here. We really need to understand what the IECC really is. But before we get in there, we need a quick refresher course on life cycles and the savings. If you have not seen the life cycle costing video, please be sure to watch it. But for now, we're going to give you just a quick little outlook of what that is. To begin, a 20-year versus a 40-year cycle. This is on any system that can give us those type of lengths of time. Understand this is accounting for inflation only. This does not account for increases in raw materials, labor, distribution issues, or anything else. Typically, we'll use a 2% per year escalation or inflation number on this. So when you look at this, as you can see, year zero would be just $0 because we're going to use that as a base, just looking at percentages. In 20 years, you're going to have 2% per year. That's a 40% increase. Plus, then you need another 100% for that system to be replaced. That's why in 20 years it'd be 140%. Now, we go another 20 years beyond that, we get a gain of 40%. Plus, we have to add the two 100% for year 20 and year 40. That means we will, from year 0 to year 40, it will cost us 380% just to get that system replaced twice over that 20-year each cycle. However, if that same system goes in and we put it in and it has a 40-year life, well, as you can see, 20 points per 20 years, we get 180 points plus the base cycle on that. Now, that shows a huge break. In our current market that we've got, which conservatively speaking is a 7% year escalation or inflation rate, you can see how those numbers vary in this and how those numbers grow so quickly, especially when we're in a market of the nature that we currently have, where just costs are getting so out of control. The longer the life cycle, the greater the savings are in the long term, no matter what the escalation is. Now, let's go back to what we talked about with Herman Channon's comments in 1984 at the AIA convention here in Phoenix. If you haven't seen our video on value engineering, you really want to go look at that. That's going to tell you what that is. But one of the things that Herman Chain mentioned is he said he learned the hard way that the better the top line is, the greater the bottom line is. What he was actually stating and understanding was that the longer cycle life materials normally cost more up front, but they generate a bottom line. As we just saw in the examples, just based off of inflation, we can actually increase almost 200% or more in some of these cases savings over that 40-year cycle. That's what he was understanding. We need this mindset, especially when we start thinking about commercial re-roofing. Why? The IECC is a building code. Unlike any other building code, the IECC offers a trade-off method to compliance. What that means is you have options, not just a single prescriptive standard. You must do this to comply. It allows us to go back and forth. Now, when we start talking about re-roofing, we have to talk about expense versus investment. What do we actually mean? An expense is outgoing funds that basically have no return. What that means is it's like money in a gas tank. You put it in, once you burn it, that's the end of it. There's no return. An investment is outgoing funds that will generate some sort of return. Example, you put money in your savings account or your CD. At the end of the period, at the cycle, you actually gain some value back, be it interest, whatever. That's what we need to understand. And as we explore the issue of commercial re-roofing, this will always be the tug-of-war that we have to balance. If you only see the new roof by itself, the commercial re-roof can become an expense. It has no value. It just you spend the money on it, and that's the end of it. If you see the new roofing through the intent of the IECC, the commercial re-roof can become an investment, as it may have a positive impact on existing HVAC systems and energy consumption. Remember, these systems have also aged, and by adding a little more insulation, making them work a little less, we might actually get them to last a little bit longer. Again, increasing the value of our return. That's what we need to talk about at this point when we start talking about the commercial re-roof. Roof and walls represent the largest elements for heat gain or heat loss, depending on what cycle we're in. And that's one of the reasons why it's such a major topic and this video exists. Walls largely last the lifetime of the building. Most buildings last, of course, between 50 and 70 years or more, depending on how they're maintained. Roofs can last 10, 20, maybe 30 years. Now, once in a while, if you get the right system, you can get a 40-year roof, which, by the way, most roofing warranties call a lifetime roof, but their lifetime actually means 40 years, really. Now, based on those previous inflation examples that we saw, we start to see how this represents significant savings potential. That's what this is all about. So let's jump into the code right now. Chapter 5 of the IEC. One of the things that this says, and again, you can see this is the existing buildings. By the way, this particular excerpt comes directly off of the IECC website for this code. And as you can see here, the whole goal of Chapter 5 is to maintain, if not improve, the conservation of energy by a renovated or altered building. So this can be viewed as the expense or investment like we talked about. The question is, what will be your choice? How do you see it? How do you approach it? Chapter 4 requires minimum insulation values for each building component. Existing buildings may not meet these requirements. That's where Chapter 5 takes over. And again, Chapter 5 allows us to maintain or improve the existing building. That's the best part about it. It doesn't require us necessarily to increase it. However, you will find when we start talking about commercial re-roof, there's a slight little caveat that doesn't necessarily mean that's what's going to happen. Requirements for re-roofing, as we can see here in C503.3.1 about roof replacement, it says roof replacements shall comply with C40213, C40214, and C0215, or C407, where the existing roof assembly is part of the building thermal envelope. This means the design professional must determine compliance, as the IEC requires a complete thermal barrier to be located entirely through one of these sections, whether we use the 402 or the 407 sections. Now, we're going to look at each one of these sections real briefly to try to help clarify what they are and what they mean. So let's go on to our first section, 402.1.3. As you can see here, this is the R value based method. The beautiful part about this is that it's fixed on just the R value based components. It focuses only on the R value. This is a relatively simple, easy to do for a design professional, for anyone. No calculations, nothing. We just match the table. That table we're looking, of course, is this complementary table, table C402.1.3. Now, this is only the excerpt dealing with the roof because that's what we're talking about. Now, as you can see, along the top part, it calls the climate zones. All the areas of the U.S. are broken up in the code to these different climate zones. You'll have to check what climate zone you're in. Also, you'll see that on the left side, it's all other occupancies. On the right, it's an R. If your commercial occupancy envelops or has an R residential component, you can look at the right side of that of that column. Otherwise, it will be the left side. As you can see here, we have insulations requirements for above the deck, for metal buildings, and for attic and other spaces. We need to understand that this table is about having minimum insulation values. It is a required base, all zones, all occupancies, no exceptions. And unfortunately, Chapter 5 does bring us back to this. But this is actually only one of three choices. The second choice now is section 402.1.4. This particular method allows us to do the calculations based off of a U factor, C factor, or an F factor. Now, of course, these are all calculated. Most engineers can calculate it out. It's not very hard to do, but it does require a little more work on the design. This focuses on the thermal characteristics of an entire roof assembly as a composite unit. Now, let's look at the table here, that companion table here, which is C402.1.4. Now, again, just the excerpt for the roof. You can see our climate zones along the top, the same two columns about other and residential, and you can see what these R values are. Now, these U factors or U values. What that is the U factor or the U value, which is defined by ASTM C1363 C1360. ASTM is the American Society for Testing Materials. They set the specs out, and by the way, that spec doesn't call a factor or a value, it just says U. That's why you'll hear these two terms interchangeably. I know when I was first introduced to it way back when I began, we referred to it as U factors. Sometimes they call it U values. I heard someone say it is a U factor, not U value. The reality is ASTM doesn't give it either one, it just says the U. This is the reciprocal of the sum of the R values for the whole assembly. In other words, each component, you add up all the R values and then you just take the reciprocal. When you do that, you get the U value. That U value you then can combine to this table. All right. The question though is, what is the C factor? The C factor is a time rate of steady state heat flow through the unit area of the construction. Now, this is set up by ASHRAE 90.1. ASHRAE 90.1 is actually the foundation of the IECC commercial section. Now, the F factor is the heat transfer through the floor induced by unit temperature differential difference between the outside and inside air temperatures. This is, again, also an ASHRAE one with pretty much most of our roofs, this may or may not work. Again, an engineer would have to be the one who will have to decide. But this tells you what the C, the F, and the U factors all are. Great little base for it. Please feel free to do more study, but it gives you a background on it. Now, let's go to section C402.1.5. As you can see here, at the bottom of the actual paragraph, it brings up equation 4.2. Equation 4.2 is the big key. Now, you'll see on the bottom of this slide and the rest of the continuing slide, it will show you all those pieces are. In a plain, simple fashion, what that really means is this is an energy modeling type of approach. It's a computer program. We can put it in. An engineer will put everything in on the envelope, the walls, the ceilings, the floors, everything. Develop this particular calculation out. This is very complex. This takes some time and does have a potential of increasing design costs. That this section is that energy model compliance to prove compliance. So now, the three things that we've just been looking at are, number one, the R value. This is a simple, easiest one to do. We have the calculation that an engineer can do for the U, C, or F factors, depending on what's available. And then, of course, the energy modeling, which is more complex of a method. Now, the downside with the last two is at the end of the day, after you do that analysis, you may still end up having to put more insulation into the roof, which in most cases mean we have to put that insulation on the deck, because going into an existing building to put insulation in the attic space or under the deck is very, very problematic, because you have buildings that are operational and you can't interfere with their operations like it needs to be. So ultimately, you may end up coming back to the same solution that the simple solution from the R value gives us. Now, I want to go back for a moment and talk about 503.3.1. It states, and this is a very, very key thing to remember. When we read this section literally, it uses the conjunction and. If you see here, not only do you have to comply with C402 or 407 if it's part of the building thermal envelope, but it says and contains insulation entirely above the deck. There is some who, when they read this, will say that once you have to re-roof a commercial building, this triggers you to put the CI portion, or that continuous insulation portion, on top of the deck to put the roof down. That is certainly a more conservative understanding, but you can see clearly here where it does tend to read and lend itself to that in a more literal sense. Re-roofing on commercial projects can be seen as an expense or an investment. Your approach will determine those answers. Compulsion or investment with return. We've went through both. If you see the CI layer deck over the deck, it looks like it's a positive, inexpensive way to comply. After calculating modeling, you could be stuck doing it. But the plus to that is when we do that and we add that little bit, we can actually help in a very, very small portion way the existing HVAC system, which at this point is already aged and needs that little bit of help. Give us an idea. When I was at the agency, we would spend $1 million re-roofing a school, and we're talking 200,000-300,000 square feet. $1 million. That's the construction cost. That's a lot of money. Yet the insulation to lay down to be compliant with this only costs $100,000, $200,000. When you look at that, those are really, really small numbers compared to what it can return. It may not be the greatest investment, but it certainly will help you. And the key, again, as we've always said and always focused, it's about making the buildings last longer, going beyond that 70 years, seeing that 100-year building. For me, if I'm being told I must do something, I tend to resist. I'm sorry, that's just my nature, and I think others of you are the same way. But if I'm doing something to gain value and I'm getting something in return, I am so much less resistant to doing that. It's got an incentive for me. Many owners focus on the design fees because that's what is the easiest thing up front to see. But they need to understand these design fees are a very, very, very small portion of the overall construction. Stop to think. Design fees are between 6 and 8% of your entire construction costs. You might be better off to focus on the larger expenses so that you can find more return in those, because you probably have better choices there rather than cutting out $4,000 or $5,000 from your design fees. The last two options provided by the IECC do come with those design fees. That's what you have to weigh. Does it weigh in? Does it weigh out? You don't know. And then there's always a caveat. Heck, we may still end up having to do it anyway. Please, as an owner especially, this is my focus to you as owners and owner reps. You've got to not focus on those small dollars generated by the design fees. We got to focus on those larger dollars that can be configured in a way to produce additional value to the project. If you want to read more about re-roofing, click the link below in the description for an article that I wrote. If you find this video helpful, you got something out of it, please be sure to like this video, subscribe to the channel, click that little bell to get notifications when a new video comes up. More importantly, let's remember, as always, design well, build safe, and maintain our buildings to give us longer life to them. Till the next time, we'll see you then. The Professor out.